So this is the third case over here, adding to any other location. Specifically, we want to add this node to some given index. Okay, we want to add this node to some given index, right? That's somewhere in the middle of this list. It could be at the end. It could be at the beginning. Right now, we're going to assume it's at some index. Sorry, not the beginning. It could be somewhere. It could be close to the beginning, but it's not going to be the head. Right now, we're going to assume that it's in between. That the index I want is in between two nodes that already exist. So, because the other alternative is that this guy doesn't exist, and that's perfectly fine, but it's not really going to change too much for how we're going to do it. It also could be that index doesn't exist yet. That's perfectly fine. But we are just going to again, try to figure this out. But one thing that we're going to need to do is that we are going to need some way to get these nodes over here. They're at some index in this list. And so I need to retrieve them. Because otherwise I don't have anything to work with. So public node E let's see. And we're going to write something called getNode over here, which will take in an int index. And this will be a big helper method for us. Once this is done, I'll test the whole thing at once with my toString. I really should have done that to begin with, but over here, I'll use the getNode. Because we're going to use that current.next thing that we did in the first video to do this. So this will return a node somewhere. This is a private method, so I'm not going to bother checking to make sure it's out of bounds because we already should be checking that by the time we call this over here. So what I'll do is as follows. I'm going to create a node called current, just like I did before. And it's going to start at the head. All right, so what I'll do over here is I'm going to go ahead and copy these guys over here, but they'll come out and be there. Rather, this will be its own thing up here for just a second. So the first node will be the head. I'm not going to bother labeling it. Let's go ahead and move all these guys down over here. Let's see, can do that. Yep, I'm going to move all those guys down over there. And let's connect these guys up. So suppose this is our linked list for the get node, right? Okay, so this is our, so I'll go ahead and mark this as head, just over here. Honestly, makes it easier. And let's go ahead and create current, just like we did before. So current is going to point to this initial node over here. So node current is equal to head. All right. What we'll do over here now is that we are going to iterate through the entire. We're going to iterate through this this array until we get to the specific index we want to be at, and then we can return that. So if I want to get index 0, let's think about this. All right, we know how to. We learned how to advance current. If I do current is equal to current.next. Then what this will do is we'll take the memory location of current.next and store it in current. So the effect of this is that this pointer would then move to here. If I did another line, if I did this command again, it would move to this node. Okay? And the interesting thing to note that I note after having done it multiple times, teaching this multiple times, the number of times I call current.next gets me to the index equal to the number of times I've called that. So if I do this twice, this gets me to index 2. If I do current is equal to current.next, this gets me to index 1. If I did it 3 times, it would get me to index 3, right? If I were to do this 3 times, Control C, Control V, Control V, Control V, right? It would go, we'd be starting here, we'd then take this, go to here, then go to here, and then finally go to here. So we'd start there, 1, 2, 3 moves to get us to index 3. So that's useful to know. So we can just throw that into a loop then. For int I is equal to 0, I is less than index, right? It's the whole thing about having a certain form, a kata, so to speak. Current is equal to current.next. Okay, current is equal to current.next. So this will advance it a certain number of times, and then we can simply return current. Notably, what's convenient about this is that if we want to get node index 0, this won't execute at all, and it will just return it. Yes, it's possible for us to go out of bounds, but we are currently going to just ignore that possibility. All right. Why? Because this is a private method, so we should be able to we should assume that this is getting called safely. Okay, so let's go ahead and grab these guys over.